All right, so here's your review for the reverse chain rule and U substitution. So when I integrate this, step one is to write what's there in the base, and I need to know where the hook comes from. So the hook comes from that base, and what's the derivative of the base I'm looking for? So the derivative of this is 5. That's the one that it needs to be. So if the hook is 5, it fits. But the number before, I go what it was over what it became. So it's going to be 5 over 2. So what it was over what it became. Wait a second. What it was over what it became. So it's going to be 2 over 5. So that when I multiply it out, it's still 2. So again, what it was over what it became. Then I can circle that hook 5 and unhook it. The answer is going to start with 2 over 5. And then we do what we know, which is add 1 to the exponent and divide, and then plus c. And you could write this as 2 over 25, but it's not necessary. All right, let's try it again. So I'm not going to worry about this. If I write it friendly, it would be x cubed plus 1 to the 1/2. And this is where the hook comes from. So the derivative of this is 3x squared. And then I compare. Well, they both have x squared, but it was a 1. And then it became a 3. So it has that fraction in front. Then I circle the hook and unhook it. And then I add 1 to the exponent and divide. Now usually when instead of dividing, I go times the reciprocal and then plus c. So this would be 2 over 9, this, and then plus c. Some trigonometry. I'm going to write this as sine x squared, like that, dx. And then it's going to come right here from this base is where the hook comes from. So the derivative of sine is cosine. So the hook is right there that it needs to be. So I can unhook this. I don't need a number or fraction because it's perfect. And then I take 1, I add 1 to the exponent and divide, and then don't forget the plus c at the end. We could also write this with the exponent in the middle, and it means the same thing. All right, last one. So if I'm integrating this one and I write it friendly, this is what I notice, is that the derivative of x plus 2 does not match what's in front. So the hook has to be like terms with what's already there. And if it's not like terms, then we can't do the anti-chain rule or the reverse chain rule. Then we have to do what's called U substitution. So what's inside the parentheses, I'm going to let U equal that. So let U equal that. Then I'm going to solve for x. So to get x by itself, I'm going to subtract 2. So x is equal to U minus 2. Then I'm going to take the derivative of both sides. So the derivative of x, the derivative of U, and then the derivative of negative 2 is 0. And then I'm going to use this and go back into the question. So now I know x equals U minus 2. X plus 2 is U. And now we have something set up. We're going to do some algebra and then do the antiderivative. So I need to remember that exponent is 1. So when I multiply that together, U to the 1 times U to the half, I add the exponents together. So that becomes U to the 3 over 2 when you add them together. And then negative 2 times U will become negative 2 U to the 1/2. Oh, and dx is equal to du, so this becomes du. At this stage, we can add 1 to the exponent, so 3 plus 2, and then I do the reciprocal. Again, I can add 1 to the exponent, 1 plus 2, and then I do the reciprocal, and then plus c. The very last step is I need to put what u equals back into the equation. So u is x plus 2. It goes back in, and you have your answer. All right, Mr. G Math over and out. Shrek over and out. Till next time. Good luck.